Hello everyone, my name is Alkesh Dhole, and today I am going to explain the topic deep reinforcement learning. After hearing the deep reinforcement learning, the question arises is why do we need the deep reinforcement learning? Or what is the use of deep reinforcement learning? It is one of the most powerful technique in modern AI, but why do we need it? In traditional AI models, they are learned from fixed datasets, but they struggles in situations where decision must be made continuously, like in gaming, robotics, and autonomous driving. Deep reinforcement learning solves this by teaching an agent through trial and error, learning from rewards and punishments. When combined with deep learning, the agents can now handle complex data such as images, sounds, and dynamic environments. In short, DRL is important because it allows machines to learn from past experiences, adapt to changing environments, and make intelligent decisions without direct programming. Further, we will look what the in this slide we will see what deep reinforcement learning consists, or what is the use of deep reinforcement learning. Deep reinforcement learning combines reinforcement learning with deep neural network. Here, an agent interacts with an environment, observes a state, task, and action, and receives a reward. Over time, it learns which actions lead to the highest reward. The deep learning part helps the agent to process complex inputs like visual frames and sensor data. This approach has been used in systems like AlphaGo, self-driving cars, and smart robots. In short, deep reinforcement learning teaches machines how to act intelligently in complex and real-world situations. In the further slide, we will see the working mechanism of deep reinforcement learning. Now, in this slide, we will see the working mechanism of reinforcement learning. Here is how deep reinforcement learning works. The agent observes the environment, decides on an action using a neural network, performs that action, and receives a reward. If the reward is good, it strengthens that behavior. If not, it adjusts its strategy. Popular DRL algorithm includes deep Q networks, DQN, policy gradient method, and actor critic models like PPO or A3C. Through repeated training and feedback, the agent improves over time, just like humans learn through practice and co-reaction. Up to here, we had seen the working mechanism of deep reinforcement learning. Now, there are some limitations and challenges on the DRL. We will see the limitations and challenges of deep reinforcement learning in this slide. The first is it needs a lot of data and powerful hardware to train the model. It is more complicated when the data is more to train the model. Training is often unstable and real time consuming, and small errors can make learning fail. Also, designing the right rewards function is tricky. If it's not accurate, the agents might learn the wrong behavior. While DRL has great potential, it still faces difficulties in stability, computation, and real world applications. These all are the challenges and limitations over the deep reinforcement learning. So, in this slide, we will summarize the whole topic. Deep reinforcement learning is where AI learns from experiences, combining deep learning and reinforcement learning to make smart, adaptive decisions. We learn why it's needed, what it means, how it works, and what challenges it faces. Despite its limitations, deep reinforcement learning continues to revolutionize fields like gaming, robotics, and autonomous systems, shaping the future of intelligent machines. Thank you.